أعوذ بالله السميع العليم من الشيطان اللعين الرجيم بسم الله الرحمن الرحيم اللهم صل على محمد وآل محمد. Welcome to another video. This video is somewhat related to the one I recorded earlier and uploaded, and that is the video which was devoted to dictionaries. And in the context of that video, I introduced a term, and that term was epistemic colonialism, by which I had in mind the hegemonic nature of the digital world and how it has insinuated itself into every aspect of our lives, and in a certain sense even colonized our minds, resulting in a certain susceptibility to manipulation of all people by the algorithm or by the people who own the algorithm. And I've mentioned this before, or I've had said something along these lines before in my various lectures devoted to René Guénon's The Reign of Quantity, which I am still working on. That series is continuing and it will be finished, inshallah. And that is this idea of Jacques Ellul, what he calls the systematic vacuity of the individual. So what I'd like to talk about in this video is something related. And here I would introduce the term epistemic privation, as well as an epistemic amnesia, by which I mean the loss of knowledge or the gradual forgetting of knowledge. So I first acquired some notion of this phenomenon many years back, more than 20 years ago, when I was living and working and teaching in Malaysia. And there was a bookshop I used to frequent in Kuala Lumpur. It was a used bookstore, and I became friends with the owner, who used to spend his time there, and he was very nice. And sometimes I would go and I would have tea and we would talk, and we used to play the Oriental game of Go, which we never really finish. It's a really long game, so, and we would just end up talking about all sorts of subjects. And one day he said to me, what do you think about the concept of lost knowledge? And I said, well, what do you mean by lost knowledge? And he said, well, there's any number of skills and deep information about things which can be lost if that information or those skills are not taught to the next generation or passed on or preserved in some way, or just simply neglected for whatever reason, for whatever other factors. And I said, yeah, I can see that. That certainly makes sense. And of course, the concept that came to mind immediately to me was no one knows how the pyramids were built. People can make all sorts of claims. I lived in Egypt for many years. The first year I lived in Egypt, I went with my kids, with my wife and my kids, every single weekend to the pyramids. These structures are absolutely phenomenal. Nobody knows how they were built, and nobody can build them today. No one. And it's not just the pyramids of Egypt. Same could be said about the pyramids that you find in South America, in Central America. They have the Aztecs, of the Maya. There's all sorts of structures as well in other South American countries where you found the ancient Inca people. There are massive stone structures, what are called megalithic structures, in Baalbek in Lebanon. There are structures of the same kind, such as Stonehenge. The list is a very, very long one. And so I think I mentioned to him about the pyramids. He said, yeah, that's right, but I can give you a much simpler example from very recent history. And I said, really? Well, what's that? And he said, the slide rule. You ever seen a slide rule before? He said to me, and I said, yeah, no, I know exactly what you're talking about. He said, yeah, but do you know how to use one? I said, no. So he was older than me, so he actually knew how to use a slide rule. And since then, I've had conversations with many people who were educated in that period, and they vaguely remember how to use slide rules, but most of them have forgotten because they don't use them. These are, of course, engineers, mainly. Because the most popular slide rule among that world, the world of the nerds and the geeks, was actually this one. It's a Faber-Castell. And there was something which was invented, this is a later model of it, which was modeled off of this Faber-Castell slide rule, and that was the HP35 calculator. When the HP35 originally came out, it was an LED. This is an LCD. This is a later re-release of that calculator. But when I reached my senior year in high school, that was the last, the year before is when they got rid of the slide rule. So in my physics class, we didn't learn how to use the slide rule. I'm sure that Texas Instruments paid for this, but everybody was provided free. I mean, you could take them home, but you had to return them an HP35 calculator. And I didn't like the HP35, not the HP35, sorry, the Texas Instruments calculator. I didn't like Texas Instruments. And I actually had this, a model of this calculator, exact same model. Later it broke, and then just for nostalgia, I bought one of these on eBay, the Casio FX8100, which I quite liked. And so I used this calculator throughout high school and much of my university years. And that's what we used to do physics, chemistry, engineering calculations. But before that, people used the slide rule. And in fact, there were no calculators at the time. There were big, or computers for that matter. There were big, complicated, massive computers. And so most of the engineers who did all the hand calculations which got us to the moon, if you believe we went to the moon, not going to talk about that. This is the brand they used. It was called the Pickett. This is a real one. I got this off of eBay, Pickett. And they were kind of nice because they were yellow, easy on the eyes. So it comes in one of these, fake leather cases. And has the instructions how to use a slide rule. And they're very nice, a yellow one. And that's why it's called a slide rule, because it had this slider portion, and it had this thing that would move around. So I quite like slide rules. I have a big collection of them. The longer they are, the better. I'll explain why in a minute. And this thing that's sliding around, you know what that's called? It's called a cursor. Yes, that's where the word comes from. So that little blinking thing on your screen, the computer, that's where the name comes from. Cursor is this thing. And it has a little hairline on it that allows you to see where you are. I don't know if that's focused or not, but anyway. So the slide rule is very good for doing multiplication. I can show you how to use it really fast. So if you want to do something really simple, just to illustrate, maybe the yellow one will come out better on camera. Let's say we want to multiply. Why don't you come over here? Let's say we want to multiply 2 times 3. I don't know if you can focus on this. So first of all, this is upside down. This is our Pickett. And you see there's a thing called the C scale and the D scale. C and D. I don't have a pen or a pencil to point with, but C scale and the D scale. So let's say you want to multiply 2 by 3. So you take the C scale and you slide the number 1. And let's say you put it over the 3. Okay, actually you're supposed to put the cursor there. Then you line up the 1 and the 3 on the C, and then the bottom scale is the D scale. This basically now gives you the 3's times table. So 2 times 3, so you slide the cursor over to 2 on the C scale, and you look under on the D scale, and it says 6. This is based on the principle of logarithms. Let's use my other slide rule. This is the Faber-Castell 283N Novo Duplex, as it says here. This was considered the Rolls-Royce of, or the Mercedes or the Ferrari of slide rules back in the day. And the reason I know this is because after this friend of mine told me about slide rules, I went and researched the subject. When I get interested in something, I really go into it. And I proceeded to get a collection of slide rules. So let's do something a little bit harder. Let's say we want to take 1.3 and multiply it by, I don't know, let's say 3. So we come over here on the D scale. We line this up with 1.3. Then we put the 1. We line that up on the cursor with 1.3. Let me set it first. Yeah. And people were really fast with these, man. Okay, so now you can check. You can see 1 is above 1.3 on the C. 1 on the C scale, 1.3 on the D scale. This is our cursor. We want to multiply it by 3, right? So we come all the way over here, and we put it onto 3 on the C scale. And then on the D scale, you have 3, and you go 3.1, 3. Et cetera, 3.2, 3.6, 3. And there it is, 3.9. Right? 1.3 times 3 is 3. I mean, these are simple enough you can do in your head, unless you become a complete ignoramus and robot. And most people cannot do math in their head anymore. So this is very good for multiplication. There were any number of other things you could do with this, which I'm not going to go into, but just for the sake of the viewer, the people watching the audience, show them this. Look at, see, you've got trigonometric functions here. You've got tangent of x, of 0.1x. You have x squared, x cubed. You have various things you can do. And these were very sophisticated. And there's another side as well. So you could do all sorts of things on these slide rules. And that's an aspect of lost knowledge. That has been lost. There is a whole channel actually on YouTube by a math professor about slide rules and how to use them. And he solves problems and so forth. And it's very interesting. I really can't remember the name of it, but you can search online and you can find it. And yeah, so that slide rule which I showed you was then replaced by this HP calculator. This is also a different kind of calculator. This uses what's called reverse Polish notation or reverse Polish logic. This is why I wish I had used one of these or converted to this earlier, because they're much better in terms of doing the calculation. So if you want to do some calculation like 456, let's say 4,546, and you want to multiply that by 12, you type in 4,546 and then you push enter, and then you want to multiply by 12, so you put 12 and then you hit times and you get 54,552. And this is very fantastic because you can do all sorts of other things. You can do trigonometry, you can do permutations, you can do combinations. This was a really, really great calculator, and I think it's still a very good calculator, but then apparently it was surpassed by this one. I just got one of these on eBay, but I haven't opened it yet. The 15C Collector's Edition, they reissued it. Maybe we should do an unboxing video. For some reason, people like unboxing videos. I don't know. So those are a couple of examples in the realm of mathematics. There's also this device. This is Japanese-style abacus. Abacuses are very good for addition and subtraction. They're not very good for multiplication, in my view, although you can do it. This is a Chinese-style abacus. I don't know what their status is in the Oriental world, but if you really practice on one of those from early childhood, people are very fast on those. It's another approach to mathematics. I mean, just briefly, what you have is you would go from right to left. This would be the ones, this would be the tens, the hundreds, the thousands, and so forth. And these numbers, these are actually supposed to be up here. This is the 0 position, but if I hold it, it's not going to work. It has to be like this. And so these represent fives. So if you wanted to represent the number, let's say 5,506. So 1, 2, 3, that's hundreds. This is 5,000. So 5,526. So that's 5 thousands, 5 hundreds, 2 tens, and 6 ones. And there's different ways of manipulating that to do addition and subtraction, and it's really very, very impressive. Another example of lost knowledge. Genon in The Reign of Quantity has a lot to say about modern science and how it's a dim reflection of the traditional sciences and how much of the traditional sciences have been lost. So this is very, very true. Especially if you take something like astrology. There are very few people who really understand how to do astrology today. And astrology now has just become a big joke. But if you look at the history of ancient mathematics and astronomy and astrology, and there was no distinction in ancient times, all of this stuff goes back to ancient Iraq and to a very mysterious people known as the Sumerians. This is an old book, but it's still good. So, I mean, this is turning into a reading list video now, but anyway, by Samuel Noah Kramer. And he actually wrote another book besides this book, which is The Sumerians, Their History, Culture, and Character. But he wrote another book called History Begins at Sumer, talking about the first of the ancient Sumerians. And it's amazing how little we know about them. Their language has not been really completely deciphered, and the fact that we even know anything about it is because of another civilization, which is their sort of successor civilization or daughter civilization, is the civilization of ancient Assyria and Babylonia, and they had a language called Akkadian, and there were bilingual texts. And Akkadian is a so-called Semitic language. I have some reservations about the way these languages are classified, but that is not our topic today. And that language is very closely related to Arabic and Hebrew, and there were certain multilingual inscriptions that were found, and there were the other languages that were involved in that inscription allowed people to back decipher Akkadian, and therefore to be able to read the ancient Akkadian and Sumerian glossaries, and that enabled them to decode many of these things. But it's there in ancient Iraq that we have the system of 360 degrees in a circle, 60 minutes in an hour, 24 hours in a day. Early calendrical science developed there. There were very ancient astronomical observations there related to divination, and that kind of astrology is called mundane astrology, the astrology of the larger cycles that govern human civilization and the rise and fall of humanity. This is also something that René Guénon was concerned with, the cosmic cycles, what are known in the Hindu tradition as the yugas. And for the ancient Greeks, the great year, or also the Platonic years associated with Plato. And along those lines, we have lost many things. I mean, how many people... Ancient Egyptian was lost as a language for centuries until its decipherment, again, through a multilingual inscription known as the Rosetta Stone. There's a book about it, an old book by E.A. Wallace Budge. You can go to the British Museum and see the Rosetta Stone. There is a whole sort of exhibition that was devoted to decipherment back some years ago. And so there's another book on the Rosetta Stone by Richard Parkinson, who's a keeper of antiquities at the British Museum, called Cracking Codes and the Rosetta Stone, or Cracking Codes, the Rosetta Stone, and Decipherment. So decipherment is another example of lost but then recovered knowledge, a kind of epistemic amnesia. The ancient Egyptian language fell out of use for many, many reasons, too complicated to go into here today. But there was an influx of of Hellenism, of ancient Greece. The last phase of ancient Egyptian was called Coptic. That gradually fell out of use, and most of the people became Muslim, and so Arabic became the language. And there are other languages whose knowledge was completely lost, completely. And it's really almost a miracle that some of these have been able to be deciphered. One of these in particular is Linear B. It was deciphered by a guy named Michael Ventris, who unfortunately died at a very young age. The Decipherment of Linear B, nice little book by Cambridge professor John Chadwick, who worked with him. But the great insight there was that Linear B as a writing system was, I think, a syllabic method of writing an earlier phase of the ancient Greek language. So that was the great insight. So this is another example of how knowledge is lost. There are lost languages. There are scripts which cannot be and have not been deciphered. So here's a book on that, Lost Languages. Very interesting read with many pictures and so forth by Andrew Robinson. And there's all sorts of other ancient knowledge. Have you ever heard of something called Atlantis? It's mentioned by Plato in which dialogue? The Critias and another one. One was one of Plato's ancestors named Solon, I believe, who went to ancient Egypt and learned the story of Atlantis. Well, I mean, was there an Atlantis? There have been probably thousands of books written on this. One of the more interesting ones is When the Sky Fell, in search of Atlantis. I think that there was a lost continent of Atlantis. But my detailed views on that obviously are not the topic of this video. But I think this is one of the most interesting books on this topic. Of this lost continent of Atlantis. There's also geographic knowledge which has been lost. There was a very interesting book which I came across years ago by someone named Charles Hapgood. Now, when I was a child, I must have been about 9 years old or something, there was this bizarre sort of fad. I suppose today we would even call aspects of it a meme. And this had to do with a book that was written by a Swiss hotel owner named Erich von Däniken. Erich von Däniken. And this book was called Chariots of the Gods. And then he wrote another one called, I think, The Gold of the Gods. There were 2 or 3. It was a trilogy. And some kind of a documentary film was made of it. And I'm sure he made lots and lots of money. And this is when the ancient astronaut idea became very popular. And unfortunately, it has been revived by the History Channel. I mean, it's a very stupid thing. The History Channel is really one of the dumbest channels now. I'm sure it still exists. It's probably on one of those streaming networks. But they have this really idiotic show called Ancient Aliens. And they have all of these kooky people that come and talk on that. And some of them were actually serious researchers, but they all jumped on this bandwagon. And it's all just a bunch of nonsensical speculation. And there's that guy with the Greek name with the crazy hair. What's his? You know what I'm talking about? I can't remember. I mean, sometimes I watch clips of it on YouTube just for laughs. Because the things they say are just really stupid, but the visual images of ancient structures and things are quite interesting. So this is when this started with Erich von Däniken. You can look him up. And I remember one of his kooky pieces of evidence that he put forward was an ancient map from the 1500s, if I'm not mistaken, of the Gregorian calendar, which is known as the Pir Reis map, which is an Ottoman map. And the map shows pieces of North and South America as well as Antarctica. And he said there's no way that people could have known about this when this map was made, which is true. And it must go back to some ancient knowledge, some ancient maps, presumably based on pictures taken from space. I mean, that's quite a leap. But that's where this started. And so I came across, so that's where my interest began on this. And I, as a kid, I thought, wow, it'd be really cool if there were aliens and they came a long time ago and, all of this stuff. But I was smart enough to realize that we have no empirical evidence whatsoever of ancient aliens and all of this. Again, I'm not saying that I know how the pyramids were built, but I guarantee you they weren't built by aliens. So you can agree with me, you can disagree with me. If you are a believer in UFOs and aliens and so forth and that phenomenon, that's your business. I am not convinced. But I was talking about Charles Hapgood. So he wrote a book called Maps of the Ancient Sea Kings. And he actually conducted a detailed mathematical and cartographical and geodetic, I think would be the word, study of this ancient map, of this ancient Ottoman map, which is featured on the cover, both the front and the back cover of this book. And in the course of his researches, they discovered some uncanny things. So it wasn't just this map that he was studying also a number of medieval maps that are known as portolans, which were used by early seafarers to go from port to port. And through a detailed analysis of these maps, he determined that the mathematical knowledge that was needed to make these maps did not exist in the Middle Ages. It wasn't there. So how did they make the maps? Well, they must have been based on yet more ancient maps, by some people or civilization that did have an advanced knowledge of the Earth. So here's our Earth, this is our globe. Something I would like to say, the notion that the ancient people thought that the world is flat is just one of the dumbest ideas I have ever heard. This is absolutely ridiculous. I mean, we have the ancient Greek, in Alexandria, in fact, mathematician and geometer Eratosthenes, who, on the basis of observations, is calculating the radius, the diameter, and the circumference of the Earth. You don't do that for a flat Earth. That's just stupid. Al-Biruni did the same thing. You don't do or try and develop mathematical techniques for spheres, something called spherical trigonometry, if you believe the world is flat. Ptolemy, the author of the Almagest, nowhere says that the world is flat. It's a question on whether it's actually rotating or not. There's a Ptolemaic system, there's a geocentric system. I'll have more to say about that later. But Ptolemy also wrote a book called The Geography, in which he developed some basic mathematical techniques for projecting a sphere onto a flat surface and therefore making a map of the world, for which he gave detailed latitudes and longitudes. Why do you do that if the world is flat? It's just a dumb idea. And it's just a myth that has been propagated to make Christopher Columbus and all this story, the story of Christopher Columbus, sound all the more dramatic. Anyway, so Charles Hapgood and his graduate students, they worked very hard on trying to determine the coordinate system for the Piri-Reis map and the other maps, the other portolans or medieval maps. So you have to have a coordinate system, right? So on this globe, there are lines of latitude, which are the circles that go this way, and then there's lines of longitude. And the lines of longitude are circles that have their center at the center of the sphere. And so longitude is measured so many degrees east or so many degrees west. Latitude is measured so many degrees north and south. So you have to have a coordinate system. You have to have a zero longitude. You have to have a zero latitude. The zero latitude we take as the equator. Well, where is the zero longitude? Well, you could put it anywhere. Doesn't really matter. Mathematically, it comes down to the same thing. It's just it's a baseline, so to speak, from which you measure. You measure east or west of it so many degrees. So where do you want to put it? You could put it at Mecca if you wanted to. You could put it in Washington. You can put it in Tokyo. So the question they were trying to solve is, well, what was the coordinate system of the Piri-Reis map and the portolans from the Middle Ages? And after a lot of mathematical work, and they even consulted the U.S. military, Air Force Navigation Office, whatever, something like that. It was some department within the United States Air Force and United States Navy, because navigation is very important for airplanes and ships. And they also helped, and they came to a very startling conclusion. So the center of the system centered on, and there were some slight variations in the maps, either on Alexandria, Egypt, or Cairo, Egypt. Now, the Cairo one is very interesting. So Hapgood doesn't say as much, but it essentially comes down to the Great Pyramid being the 0 point from which things were measured. And nowadays, like on the globe I just showed you, the zero meridian longitude is measured from an observatory in a place called Greenwich, which is it's in England's United Kingdom. Hence we speak of Greenwich Mean Time. So we have so many hours ahead or behind Greenwich, because the time is also a question of longitude. If you're on the same longitude line, you're in the same time zone. And this is a recent phenomenon. I don't know exactly when it became an international convention to measure from Greenwich, but when the whole thing was still not settled, there was a astronomer named Piazzi Smith who had gone and studied the pyramid in Egypt and made detailed measurements and so forth of its structure. And he had proposed that the Great Pyramid be used, in other words, its position, as the 0 point. Of course, in the end, they decided on Greenwich, but that's the story. So Charles Hapgood, that's why he spoke of what he called the ancient sea kings, and an ancient civilization that had made these maps, and this knowledge was passed down. There's an extraordinary picture here on page 52 of Maps of the Ancient Sea Kings, where they do an equidistant azimuthal projection centered near Cairo. Notice how they say near Cairo. They don't want to say the pyramid. Why don't you focus on that? Look at that. So this is a very, very interesting book. And Hapgood wrote another book on, it was called The Path of the Pole. And it was about pole reversals. So we have a North Pole and a South Pole. Scientists really do not understand, at the deep level really, what electricity and magnetism are. They can describe them to a certain degree. But what are they? So he wrote this book called Path of the Pole, in which he presented documentary evidence on the basis of geology and other sciences of magnetic pole shifts in history. And he wrote another book, I think, also on continental drift and so forth. These are 3 famous books that he wrote. So the idea that it was advanced that there have been cataclysms in our past. Now this is very important again in relation to what Genon says in The Reign of Quantity about the yugas. So each of the yugas, you have the golden age if we use the Greek designation, and then the silver and the bronze, and now the iron age, or what in the Hindu system is called the Kali Yuga. And each age ends. It's the end of a world, not the end of the world, end of a world. And there's always some sort of a cataclysm. So there have been shocking cataclysms in the past, of which we have a kind of amnesia. Again, epistemic amnesia, epistemic privation. Knowledge of any number of these sorts of things has been lost or forgotten. There's another person who writes on these things. He's much better. I remember I came across his books before he became this big sort of sensation. I mean, this was before the internet was this big, and it was a person named Graham Hancock. And I had read his books more than 20 years ago. Now he's become very famous. He had a couple of Netflix series, and he was interviewed by the indefatigable Joe Rogan, on the Joe Rogan Experience. And now everybody knows who Robert Bauval is. But I remember I had read his book, Fingerprints of the Gods, when it first came out. And years later, I met him, actually. He came to and gave to an event in Dubai, and he came with his collaborator, Robert Bauval. And they've done a lot of interesting astronomical investigation of the pyramids as well as the Sphinx. And they have argued for a much, much later date for the construction of the Sphinx, something like 10,500 BC, based on certain astronomical alignments. They're also of the view that the 3 pyramids of Giza were built in terms of an alignment of the constellation, the portion of the constellation known as Orion's belt. That those 3 stars are actually mirrored in the alignment of the pyramids, 3 pyramids at Giza. Very interesting bunch of people. So Bauval has also written books as well, independently of Graham Hancock. Graham Hancock then later started writing about all sorts of other things which were not of interest to me. But overall, his investigation of the ancient civilizations and so forth are quite interesting. But I was talking about cataclysms. And this is a very neglected book. This is called Cataclysm, Compelling Evidence of a Cosmic Catastrophe in 9500 BC. I'm not sure if I mentioned this book when I started my series on Genon. It was a while ago. I don't quite remember, but this is an important book. And I want to just share a couple of things from this, and then I'll conclude this lecture. Again, when I was very young, I was in the 5th or 6th grade, I came across a book. I wish I had kept it. It's probably worth money. Or maybe not. I don't know. I've not checked. But it was a strange title. It was called The 12th Planet by Zecharia Sitchin. And I read that, and that was the first I had ever heard about ancient Babylon and the idea of the Nephilim and the Anunnaki and aliens again. It was very much like Von Daniken, but Zechariah Sitchin seemed to be someone who actually knew these ancient languages. And I say seems because to really know, I would have to know, and I don't know Akkadian. It really is something I should learn. I hope I can one day. So he argued that the ancient Assyrians and Babylonians, and I don't agree with this, that they were created by an alien race that came here. They were known as the Anunnaki, and he says that the fallen ones that are mentioned in Genesis as the Nephilim were this alien race, and he's got all sorts of ideas which I find very, very hard to swallow. But there is a very peculiar ancient Babylonian cylinder seal, which is in a museum in Germany. I think it was East Germany at the time. And it shows the sun with 11 planets. Now, there are modern-day Assyriologists who like to debunk all of this, but the cylinder seal is designated VA/243 in the State Museum in Berlin, or more specifically, the Vorderasiatische Abteilung of the State Museum in Eastern Berlin. And it is mentioned in this book, Cataclysm, in chapter 15, which is entitled The Mesopotamian Connection. Mesopotamia is one of the names for Iraq, ancient Iraq. And this is, you can actually find this online. Maybe when we edit this video, we can put an image. But there is a tracing of it here on page 216. You can just focus here, and where my finger is pointing there, you can see a star, a sun picture, just like a child may draw, with a bunch of smaller circles, which are planets that are circling around it. And then this is the enlargement of that image in the middle of the page. So people have argued that this is the sun with 11 heavenly bodies. So it says here that, let me see. A baked clay cylinder seal made by the Akkadian civilization of Mesopotamia and preserved as a specimen VA243, we already said all this, depicts the solar system as known to the Sumerians in the 3rd millennium BC. It shows 11 globes encircling a large rayed star representing the sun. The globes are generally thought to be planets, and their disposition is seen more clearly in the figure which I showed you. So he goes on to say that discounting tiny Chiron or Chiron, modern astronomy recognizes only 9 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. If we elevate the moon to planetary status, which the ancients did, then we have a total of 10 planets orbiting the sun today. On this basis, one planet, if we look at that cylinder seal, is currently still missing from the earlier Sumerian total. Why, therefore, do the modern and Sumerian totals differ? Is this difference real or imaginary? Did the original seal makers err in showing 11 planets? Could there really have been another planet known to the Sumerians, as yet unknown to us or lost since their day? So, in terms of the context of this cataclysm that they argue for, they say that there was some sort of explosion of a far distant star out of our system, and it ejected a massive body that came through the solar system, tearing through and upsetting the gravitational balance and so forth, changing the orbital rotational direction of Venus, for example, taking off various moons, and then slamming into and smashing and exploding a planet which would have been in between the orbits, I think, of Jupiter and Mars, which is the asteroid belt. And so this is what they're arguing for. So you may consult the book, but what is interesting is the knowledge of ancient astronomy and astrology that the Mesopotamians had. So in this chapter, he's arguing for that, saying that, this is not just some artistic imagination. The ancient Assyrians, Babylonians, who were also known as the Chaldeans, were very accomplished in this area. They weren't going to make some sort of a mistake like this. And he argues for the deep knowledge of astronomy. So he says, while Nicholas Copernicus is justly called the father of modern astronomy, in reality he only rediscovered in 1543 the central position of the sun in the solar system. For the same celestial arrangement was apparently known to Aristarchus of Samos in the 3rd century. There is a book on Aristarchus of Samos, which I do have, but I don't have in front of me right now, by Heath. So this notion of heliocentrism was an ancient idea. And we see it depicted, or we seem to see it depicted, in this cylinder seal. But there's a very, very important paper, which is in a collection called From Deferent to Equant, which is a collection of studies which were made on ancient and medieval astronomy, especially Islamic astronomy, in honor of someone named E.S. Kennedy. And there is a paper in this by the scholar of ancient astronomy and mathematician B.L. van der Waerden, entitled The Heliocentric System in Greek, Persian, and Hindu Astronomy. It's a very, very serious paper with a lot of mathematics and so forth, but he's essentially saying that if you study what we know about Aristarchus of Samos and other ancient astronomer mathematicians like Seleucus of Seleucia, if I'm pronouncing it correctly, who was an ancient Babylonian astronomer, as well as the system which we find in ancient India in the works of a guy named Aryabhat, we realize that the mathematics that they are using and the mathematical assumptions they are making involve a rotating Earth. And there's no need to have a rotating Earth in a geocentric model. Basically, a geocentric model and a heliocentric model both will work to describe what you see when you look up in the sky if you were on the Earth. But they were working with certain mathematical notions that involve a heliocentric system. Now, this is based on a detailed mathematical and astronomical study of the texts that survive of those people that I cited, as well as Al-Biruni, as well as someone named Abu Ma'shar al-Balkhi. These people lived in the Islamic world about 1100 years ago. And B.L. van der Waerden is arguing for a very ancient knowledge of heliocentrism, all the way back into the BC. Almost, he doesn't go so far as to say to prehistoric times, but ancient Babylon, that's a very long time ago. That's 1500 BC, something like that. In other words, about 4,000 or 5,000 years ago. That's a long time. And there have been other people who have studied ancient Babylonian astronomy, especially someone named Otto Neugebauer. And Otto Neugebauer says that these ancient astronomers in ancient Babylon, they used certain pre-packaged algorithms for calculating the positions of planets, which they themselves do not seem to have derived. They're called procedure texts. There's a quotation here. It says, Assyrian, Chaldean, and Sumerian astronomers accurately monitored the movements and positions of many celestial bodies relative to Earth and to one another and kept precise ephemerides, which means tables that predicted and listed the future positions of the celestial bodies. These tables were examined by Professor George Sarton. Sarton is a very famous scholar of science, the history of science. Sarton found that they were computed by two methods, which, as Professor Neugebauer, Otto Neugebauer, subsequently discovered were based not on observations by the astronomers who produced them, but compiled from some fixed mathematical schemes which were given and were not to be interfered with. He says this in his book, The Ancient Sciences in Antiquity, or The Exact Sciences in Antiquity. Neugebauer is huge in this field. He is the biggest name. He really founded the subject of the history of ancient astronomy and astrology. He taught at Brown University. A great student of his was David Pingree, and others. And he compiled a book. It's in 3 volumes. It's entitled one moment. It is entitled astronomical cuneiform texts in 3 volumes. And the guys who wrote this book, Allen and Dallaire, they reference him, and that's where this quote is taken from. I went and verified this. I don't have a copy of this book. I went to London, I went to the library of the Warburg Institute and checked, and that's exactly what Neugebauer says. And Neugebauer says further that we ourselves do not understand the mathematics of this. We don't know where the ancient Sumerians got this from. That's extraordinary, but it's buried in these footnotes and things which people don't really read. Now there's another scholar, someone by the name of Rumen Kolev, who is Bulgarian. And he has collected together all of the information that is available so far in the Neo-Assyrian records of what were called the ancient astrolabe texts. And this is published by Eisenbrauns, which is an imprint of the University of Pennsylvania Press. The University of Pennsylvania is the preeminent place in America, along with the University of Chicago, for the study of ancient Assyria, Assyriology as it's known. And he argues that there are 3 or 4 layers in these ancient astrolabe texts, and that the oldest layer goes back to the middle of the 6th millennium BC, 5500 BC. In other words, there's a knowledge of heliocentrism that is that old. So if you add the 2000 to 2024 to that, that's 7,724 years ago. That's crazy, if you think about it. And this is another example of lost knowledge. Just to wrap things up, this volume, From Deferent to Equant, that contains van der Waarden's paper, was edited by a guy named George Saliba. George Saliba is a professor of Islamic astronomy, if that's the word, Arab astronomy, at New York University. He wrote an interesting book called Islamic Science and the Making of the European Renaissance. His collected papers on the subject of Arabic astronomy are found in this book, A History of Arabic Astronomy, Planetary Theories During the Golden Age of Islam. He's a very serious guy. I've had the pleasure of hearing him lecture 2 or 3 times in my life. I've met him. I had breakfast with him once. We were both at a conference back at the end of 2013 in Beirut. He's a very learned fellow. And he argues in this book, and I heard him deliver a lecture on it. Which book did I mean? This book. When I said this book, I mean this book, published by MIT Press. That there were some ancient discoveries in the Islamic world that were used by Nicholas Copernicus, which he doesn't explicitly acknowledge, probably in his view due to cultural reasons, the bias against Muslims at the time, and also because of they were basically at war with the Ottoman Empire. But Copernicus uses certain kinds of mathematics to come up with the so-called Copernican heliocentric theory, resulting in the so-called Copernican revolution. And these involve 2 mathematical discoveries that that Copernicus learned of through the works of Ibn Shatir. Ibn Shatir derived these from the work of the Shia scholar Nasiruddin Tusi, and they have to do with what's called the Tusi couple and another thing called the Urdi lemma, that have to do with modeling circular motion in a certain geometric way, as known as the Tusi couple. At any rate, this is also something which is just not mentioned. So whether that's a case of epistemic amnesia or privation or just not mentioning for whatever reason, that's another interesting example. So I don't know, I've just been talking about things which interest me under the general rubric of lost knowledge. I hope you found it interesting, but there are many examples of this. And if knowledge is not preserved and passed on, it is lost. So we will conclude there, and I wish you very well. Thank you for watching.